Today is the 3rd of June 2024, nearly a year that we started putting out videos. And it was half term last week. Um, I, I normally, at times I take the break, at times I do not. But I just wanted to have a pause and think about what I'll do next. Okay. Thank you everyone who have subscribed, okay, to our channel, who are following us, who are liking and sharing our videos. Okay. I would like to hear your stories if you are using this platform and it's helping you and it's broadening your knowledge in maths and helping you solve questions and understanding questions. Please just leave us a comment, a nice comment. Okay, thank you very much. Um, if the account is not yours, please ask permission from the account holder. It's very, very important. Um, in the comment section, you always see, uh, please follow my notes slash script, which I'll encourage you to do. Okay, because math is a lot of numbers. When we're doing status, including sets, SURDS, um, like square root of 2, square root of 2, the were times also square root of 2, and then, or 2 root 2 root 2, okay? And it's the same as square root of 2 times square root of 2. So if it's the first time you are watching it, and maybe however you learned it, it wasn't said like that, you might be a bit confused. So please go follow my notes. If you hear something, go by the notes, okay? Please don't say, just take what I say. Go by the notes, okay? And then please, we are back. Beware of scammers, okay? They are everywhere, through emails, through WhatsApp, through Messenger. If you've not heard me said anything, it's not coming from me. Okay, if somebody re-edits my videos and slip in something there, please don't chat with people thinking you are chatting with me. It's not me, please. Okay, thank you very much. Recap. We've been looking at different types of probability questions. Okay, um, we did probability earlier, so I decided to do this as revision for the higher students, and it will benefit the foundation student as well. So have a look. Okay, at the moment, it's exam season, so if you've not been watching for a while and you just want to wait overnight and cram, I don't know, yeah, unless you have that learning capacity, okay, because there are different kinds of learners. So I assume there are a few people among us who know how to cram well. I don't do that. I don't know how to do that. If I have something to do, I have to start very early and start learning it, little by little. So if that is how you learn, well, good luck. Okay, so we've been doing a lot of probability questions, okay, and when to use or and uh, the times law, and when to combine Okay, mutually exclusive event. We did it earlier, and then I re-emphasized some part again. We did dependent and independent probability questions, where some you will replace and some you will not replace. We've done the tree diagram. Please go back and watch. Okay, it's very very helpful, and we did a lot of questions. Okay, and we did a lot of sets and mental math to help us think fast, and so that we'll be on top of our games. Okay, now I want to pause the mental math for a bit because I can give you mental math forever. But what I want to do today is revision on the circle theorem. I have a video on that, but there was because I have learned it over and over again. When I look at a question, I know what to apply, but at times I don't know the name. So I decided to go back again and bring the theorem in the starter uh, section so that this time around we will tell you the name, because there was a question that I solved and they were asking me for the reason what I the circle theorem I use, so I had to Google it. Okay, now today's theorem, that is our first theorem. Okay, angle in a semicircle is 90 degrees. So this is a semicircle. The radius, the diameter goes through the center, which you know. Okay, so if you have a circle and a diameter through the center, and you have two chords as you have, that angle will make a 90 degrees to the circumference. Okay, as you can see here, we've used this to solve a lot of questions. Okay, and then that point here is the center. So if you have a diameter like this and you have two chords joining them, this angle on the circumference is 90 degrees. So if you know that this is 90 and you've been given this angle, okay, then you can find this angle as well. Okay, so that is our first theorem. So I'm going to take each theorem for our starter and we'll go over. And this is angle in a semicircle is 90. That is our semicircle here. The circle divided into parts, okay, and this angle here is 90. So if you apply this to solve a question and they ask you for a reason, you will say angle in a semicircle is 90. Now today we want to talk about sector of a circle questions. We know we've done a lot of circle. If you've done it from primary school, and we've done sector questions. So this is also like a revision. Okay. So some today we are going to look at some sector questions. Okay, and that will be our first video. So today's example, a sector of a circle has radius 8.3 centimeters. Okay, a sector of a circle has radius 8.3 centimeters. Find the arc length and find the sector area. Okay, so this is a sector. We did it earlier in the beginning, like last year, I think June, July, And then I said to you, assuming you had a full pizza and you cut them into a, a piece like this, that is a sector. Okay, a sector is different from a segment. A sector comes into the center, a segment doesn't. Okay, now this is the radius 8.3. Okay, now this sector has an angle of 90 degrees, so it's like a 1/4 of the circle, because the full circle will add up to 360. Now this is also not to scale. The first one is to find the arc length. So the arc length is from here to here. Assuming this point is A and that is B. So if you are assuming you are walking in real life and this is a field and you walk from here to here, you want to find the arc length. The sector area is the whole of this area here. Okay, so the arc length is like part of the circumference. So we know that a full circumference is 2 pi r. Now that you know the angle, you are going to use arc length is theta over 360. That is your theta here, the angle, times 2 pi r, because you want the distance, okay? And at the end, remember your unit. So let's look at that. So it's 90 divided by 360 times 2 pi r. R is 8.3 centimeters. At the end of the day, it's arc length. So our answer will be in a length form, centimeters. Now, if you use your calculator appropriately, okay, that part here is 1/4. 90 divided by 360 is 1/4. 2 pi r. So 2 times 8.3 divided by 4 times pi. If you do that on the calculator, you get 13.0 centimeters. Okay. Now remember your units. Okay, because we are looking for a length. Okay. So the radius was given to you in centimeters. So the arc length will be in centimeters. And that is your formula for your arc length. Okay. 3.0 to 1 decimal place, or 13 centimeters. Two significant figures. The nearest whole number, the nearest centimeter. Read the question to the end and find out what they're asking you to do so that you can collect all the marks. Now the second is find the sector area. So the area is all of that, this part here. Okay. Now because you are finding area, the area of a circle is pi r squared. So this sector is a quarter of a circle. So again, theta over 360 here times pi r squared. Theta is 90 times divided by 360 times pi. R is 8.3 centimeters all squared. Pi r squared is the area of a full circle. Okay, so if you do this rightly on the calculator, you get 54.1 centimeters squared. It's the sector area. So your answer will be centimeters squared. Okay, 54.1 to 1 decimal place If they ask you to leave it to the nearest whole number, then you leave it as 54. Okay, so again, read the question to the end and find out what they are asking you to do. Okay. Now, another example. Okay, our examples are not to scale. Okay, they are not to scale, so be mindful of that. This is 145 degrees. The radius of the sector is 2.9 centimeters. Okay, so remember in the end, just your unit to be centimeters. Okay, now again, find the arc length and find the the sector area. The arc length, as we did in the previous example, is theta over 360 times 2 pi r. Okay, the length from this part here, as when you walk all this distance and you stop here, that is the length you are looking for. So 145 divided by 360 times 2 pi, your r is 2.9 centimeters. So that is what, so immediately after I've said, we managed to use the formula and set up the equation. Everything else is calculation. So assuming it's in a calculator paper, 145 divided by 360 times 2 pi r. R is there. Assuming they ask you to leave the answer in pi, then maybe it's a non-calculator paper. So you don't add pi, you guess the answer will be something pi. Okay, but I'm assuming here that we are leaving our answer in one decimal place. So on the calculator, to one decimal place is 7.4 centimeters. That is our arc length. Now the sector area again is theta over 360 times pi r squared. So the theta here, the angle in the sector is 145 divided by 360 times pi r 2.9 all squared. Immediately you are able to use the formula and put the numbers how it should be. Everything else is calculator. So if they ask you to leave your answer in pi, you just simplify the numbers and leave your answer in pi and add your units. Sector area. So our unit in the end will be centimeters squared. Okay. I'm assuming we are leaving our answer to one decimal place. Okay, so after everything on the calculator, I use calculator to do it. Okay, it's 10.6 centimeters squared. Okay, one decimal place. Let's look another example, and then again, not to scale. Okay, so that is our sector. It's 100 degrees, and we are finding again the arc length, and we are finding the sector area. So the arc length again is theta over 360 times 2 pi r. The angle in the sector is 100. So 100 over 360 times 2 pi, r is 8.4. Again, on the calculator, when you use the calculator right to one decimal place, is 14.7 centimeters. Okay, if they ask you to leave your answer in pi, okay, please don't add the pi. Just simplify the numbers, write pi, write your units, and leave. Okay, now find the sector area. So again, here we need to leave it in the right units. Okay, so it will be theta 360 times pi r squared. Okay, where r is 8.4 centimeters. Theta is an angle, so 100 divided by 360 times pi r squared. Okay, so here, so again, if we simplify to one decimal place, we have 61.6 centimeters squared, one decimal place. Okay, so this will be our first video on sectors we are just revising, because these are things you do earlier on, and then you end up forgetting. When the paper come and you see it, it's like, oh God, I've done this before. Okay, just remember, it's the angle divided by 360 times, um, if it's length, 2 pi r, and length, your answer will be in centimeters, meters, decimeters. If it's area, it will be theta over 360 times pi r squared, where r is the radius of the sector, okay, or part of the sector that is making the circle. Please subscribe. Okay, thank you very much. Invite other people to subscribe as well. Share, like, follow, nice comment. I appreciate it. Follow my no/script. Okay, if the account is not yours, just please ask permission from the account holder. And beware of scammers. Don't give money to any charity saying that they are working or they are collecting money on behalf of this platform. We are not doing that, okay? Thank you very much for watching today's video with me, and I'll see you in the next.